Hello friends, welcome to Term Science. In this lecture, we will discuss about performance evaluation of boilers. First, we need to know why we need to do the performance evaluation. For example, when we are purchasing boiler, we would get nameplate details, which contains the design parameters of the boiler. Initially, when operating boiler, it operates according to its design parameters. But for a period of time, we need to check whether this boiler operates according to its design conditions or not. If it is operating according to its design condition, then no issues, no worries. If it is not working according to its design condition, then we have to do inspection. Why we need to do the inspection? If this boiler is not generating a particular mass flow rate of the steam, or a required pressure or temperature, what will happen? We are giving fuel input where it consumes same amount of fuel but not generating the required pressure, temperature and mass flow rate. It is economical loss. So we need to do regular performance evaluation of boiler. Okay. Now what are the parameters that affect the boiler? That's very important. Here I have mentioned few parameters which affect the boiler. First one, poor combustion. If we are supplying insufficient oxygen, the combustion not that much good. If we are using the less quality of fuel, again there is a problem in combustion. To make complete combustion, even we have to give more amount of air, that is we call excess air. Then only the combustion will be good. If the combustion is not good, then what will happen? The performance of boiler will be reduced. Next one, poor operation and maintenance. When we talk about maintenance, if you use coal-fired boiler, we know coal has more amount of ash and moisture, even though tar. So we have to regularly clean the boiler for the better heat transfer rate. When come to operation, we need to have correct level of water. We need to check water flow rate and steam flow rate, and also we need to check the air flow rate to the combustion chamber. Then only the performance of the boiler will be good. Next one, heat transfer fouling. We know that water will form scaling inside the tube. Similarly, the star also will form a layer in the combustion chamber. This assists the heat transfer rate. So we need to do the regular cleaning of the water tube as well as the combustion chamber. Next one, fuel quality. As I told you, we need to use better fuel quality which has higher calorific value, lower ash content, lower sulfur content. Then only the performance of the boiler will be good. Also the quality of water what we use. So these are the few parameters which affect the performance of the boiler. Then how to do performance evaluation of boilers? That is question mark. For example, let's take automobile. To test the performance of the automobile, what we do while we purchasing, we know the mileage and we compare that mileage with current mileage. Then we come to know either it's working good or not. For example, you take while purchasing is giving 40 kilometer per liter and current it will giving a 30 kilometer per liter. Then there is a 10 kilometer difference. Then what we do? We take our automobile to mechanic. We will inform to him. He will check fuel injector, carburetor, or air filter, or overheating. Everything he will check and he will fix it. In such a way, we have to do for boilers. So for boilers, what we do? So for boiler, what we do? The function of boiler is to generate the steam. So how much steam is generating? How much fuel is consuming? By using this, we can do the performance. Also, we need to find out the efficiency. So here the two tests we are going to do. First one, evaporation ratio. Second one, efficiency of the boiler. First we will discuss about evaporation ratio. That one we call actual evaporation ratio. Let's take example a boiler. To run the boiler, we have to supply some amount of fuel, that may be coal, diesel, whatever it is, and it will generate the steam. Let's take the mass of fuel consumed by the boiler is mf and steam that is generated ms. If you see the definition, it is defined as the ratio between mass of steam generated per hour to mass of fuel consumed per hour. It is denoted as MA is equal to MO dot S divided by MO dot F. This actual evaporation can be also calculated ms divided by heating area or ms divided by the combustion rate volume meter cube. So we have three formulas to find out actual evaporation ratio. But this actual evaporation ratio is not up to the mark to find out the performance of the boiler, because you can see here it is mass of steam generated. That's it. It's not mentioning either dry saturated steam, wet steam or super steam. This can be whatever it is. But we know one thing, at 100 degrees Celsius the steam quality is different compared to the 200 degrees Celsius at a 1 bar pressure. The steam quality will vary. If it is 14 bar, again the steam quality will vary. So this is not applicable to find out the performance evolution of the boiler. So that what we do, we go for equivalent evaporation ratio. So here let's take example, we have boiler. We are supplying some amount of fuel and it generates the steam. The given fuel is MF and generate steam is MS. To generate steam, we need to supply the water. The how much amount of water we are supplying, the same amount of steam it will be generated. That's why we have taken M over dot S. Now let's take example. We are supplying water at 100 degrees Celsius at 1 bar pressure. It is saturated liquid we call. And it generates steam, saturated steam at 100 degrees Celsius 1 bar. Just phase change occurs. 100 degrees Celsius liquid to 100 degrees Celsius vapor at a pressure of 1 bar. For this, it required energy of 2257 kilojoule per kg of fuel. Or we can say during the saturated liquid to saturated vapor, it will absorb 2257 kilojoule of energy. Now we know the actual evaporation ratio, that is MA is equal to MS divided by MF, that is per unit time everything. We can see here, if I take the enthalpy for saturated vapor HS and enthalpy of saturated liquid is HF divided by this 2257. What will happen for this case? This also will get cancelled. This also will get cancelled. Then we have MS divided by MF. But if it is super steam, then this value greater than 1 and we can multiply with MS. If it is wet steam, then what we do? This value will be less than 1. Then again we multiply with MS, will get lesser value. If the steam has the different pressure, again this HS value will different and again this value will be higher and we can multiply with MS. Now let's see the definition. Equivalent evaporation ratio is defined as the evaporation which would be obtained if the feed water were supplied at 100 degrees Celsius and converted into dry saturated steam at 100 degrees Celsius 1 bar pressure. We know that MA is equal to MS divided by MF. This equivalent evaporation ratio is denoted as ME, that is equal to MS dot divided by MF into HS minus HF divided by 2257. This HS may be saturated steam, that is HG, wet steam H is equal to HF plus X, HFG may be superheated steam, H is equal to HG plus Cp of steam T superheated minus T saturated at a given pressure. Remember that. This is the feed water enthalpy and this factor is known as the factor of evaporation. Factor of evaporation we call. So this will be always greater than 1 and we can multiply with mass of steam where we get equivalent evaporation ratio higher than the actual evaporation ratio. This equation can be written as, this one is nothing but MA, that is M dot A HS minus HF divided by 2257. This will give equivalent evaporation ratio. This enthalpy difference is nothing but always the steam generated enthalpy minus feed water inlet enthalpy. Always remember this difference. Thank you for watching. In next lecture, we will discuss about boiler efficiency and the merits and demerits also we will discuss. If you like this video, kindly share to your friends. If you have any doubt, give in comment box. I will reply to you. Don't forget to subscribe our channel. Thank you.